All right, this is one of my favorite lessons to teach all year. So what we're going to do today is we are going to work with trigonometric identities, and they're equations that involve the trig expressions that are true for any value that you plug in, but we have to show that or verify that. In order to do that, we have an equation, we work on one side, and we get it down to match the other side. We only work on one side. It's not like solving an equation in Algebra 1 or something. So the guidelines, work on one side, choose the more, it's better to choose the more complicated side and try to simplify it. But after some practice, you'll see there's always one side that's probably a little bit easier. And there is more than one way to do these problems. You might pick a more difficult way, but you might get around to it. And just try something. A lot of times I'll start one of these problems and what I've tried doesn't work. So I just erase everything and then try again. So you're going to need to write this stuff down. Okay, so there are different tools that you can use, but the ones that we're going to be using today are rewriting sines and cosines as reciprocal functions. We're going to be using the Pythagorean identities and applying even and odd identities. You might need to pause to write those down. I'm going to go ahead and start. I'm going to take my time because this could take longer than 15 minutes. Okay, so we're going to go ahead and start with A. And I see that I've got tangent times cosine times cosecant. So I probably first want to just write those out. We know that the tangent is the sine over the cosine. So I'm going to first rewrite the tangent as sine over cosine. And again, when you try something, you don't necessarily know if you're moving in the right direction. And the cosecant is the reciprocal of sine. Now let's take a look at, I always put an equal sign there. That equal sign on the right lets me know that I'm working on the left side of the equation. If I was working on the other side, I would put the equal sign on the left to let everybody know which side I was working on. So you can write the 1, but I'm not going to. So now what do we have? We've got a denominator and a numerator here. Those cosines cancel, these signs cancel, and that just leaves us 1. So we ended up with 1, and now we can say equals 1. Check. Let's go to B. All right, so we've got secant minus another expression, sine times tangent equals cosine. The left side is a little bit more complicated. There's more going on, so I'm going to start on that side. And I'm just going to rewrite. If I rewrite, the first thing I notice is I've got 2 terms here. If I rewrite secant, I'm going to have a cosine in the denominator. If I write tangent, I'll also have a cosine in the denominator. That way I'll end up with 2 fractions that I'm subtracting that have the same denominator. So that's how I'm going to start. And this just takes practice. So this is 1 over cosine, and you need to write the theta minus, this is the sine of theta. And that's, you can just put that over 1 if you'd like. And then tangent is sine over the cosine. Okay, so now what that says, and I got to put my equal sign, is 1 over the cosine of theta minus, this is sine squared of theta over the cosine. Well, now I've got 2 fractions that have the same denominator, and I can add them together. So I'm going to rewrite that as 1 minus sine squared of theta over cosine of theta. Now, over here, I'm going to write this for you. The Pythagorean identity, sine squared x plus cosine squared x equals 1. If I subtract sine squared from both sides, and I just rearrange this identity, watch what happens. I end up with the cosine squared of x equals 1 minus sine squared of x. So I can rewrite 1 minus sine squared as cosine squared. You might have to look at that again. So I'm going to rewrite 1 minus sine squared. I'm going to substitute in cosine squared. My denominator is cosine. That looks like a null. Empty set, but it's not. Okay, so that equals cosine, because one of the cosines in the numerator and one of them in the denominator will cancel. I'm running out of room. So when I run out of room, I'm not going to just write wherever I want. I have to, in an orderly fashion, show people where I'm going. So maybe I'll just go like this. Okay, so now I can simplify that. That will just be, sorry, there we go. 1, oh no, cosine theta, and that's just over 1, and that's just equal to cosine of theta. And the other side is cosine of theta. So it's been checked. Let's go on to C. You might have to rewind to look at that one again. Ooh, this one looks fun. These are like puzzles. All right, so sometimes we're going to try something and it might not work. So I'm looking at this, and I notice that on the left, I've got two fractions with different denominators. And on the right, those denominators, those two same, they have been multiplied, right? So it's sine times cosine. So I have to somehow get them to, the denominators have to be the same. So what I'm going to do is I'm going to start with, and I'm just going to erase this stuff up here. I'm going to start with multiplying each fraction by the denominator it's missing. So I'm going to multiply this side by cosine of x over cosine of x, and I'm going to multiply this side by sine of x over sine of x. Now I'm going to rewrite that. So cosine of x times 1 plus cosine of x over sine cosine. Okay, plus this is sine of x times sine of x, so that's sine squared. And this is, now I've got the denominator the same in both of these fractions. So that means I can add those two fractions together. Now before I do that, I have to distribute this cosine to the 1 and to the cosine. So that numerator is cosine plus cosine squared. So I'll go ahead and rewrite that first. Well, I can do it together. Cosine plus cosine squared, oh, don't forget my x, plus sine squared of x all over sine cosine. Can't forget my equals. All right, now what do we have? I can see this Pythagorean identity right here. That's a 1. So I'm just going to go ahead and rewrite that as a 1, and then it's going to look like the right side of the equation. Cosine of x plus 1 over sine of x cosine of x equals other side. Hey! Now notice, I'm not dividing both sides by, I'm not solving the equation. We're only working on one side because we're verifying that this is an identity, that they are actually equal. Moving on to D. All right, so sometimes, and there are different tools that you can use, okay, but I'm going to go ahead and I notice that my denominator here is cosine squared. And just as we were learning earlier, 1 minus sine squared equals cosine squared. So I could change this denominator into 2 of those. So I'm going to go ahead and do that. And then we'll have to probably factor in this. We'll just see what happens here. I haven't done this yet. All right, so I'm going to start on the left. 1 plus sine theta over, now I'm going to rewrite cosine squared as 1 minus sine squared. Okay, equals. Now, if I factor 1 minus sine squared, leaving the numerator the same, I will end up with, this is the difference of 2 squares. So this is 1 plus sine of theta and 1 minus sine of theta. It's the same thing as if you're factoring, like, I don't know, x squared minus 9. That's going to be x plus 3 and x minus 3. Okay, so now let's look at it. Now I've got a factor in the numerator and in the denominator, and they're the same. So I can cancel them. Cancel, cancel. The reason I can cancel those is because these factors in the denominator are being multiplied. If they were being added or subtracted, I wouldn't be able to do that, but you can cancel factors. So now what do I have left? 1 over 1 minus sine of theta equals the other side, 1 minus sine of theta. Check. Moving on. All right, this looks kind of yucky. like I'm going to have to write a lot. I'm going to go ahead and multiply this out because this is sine of x plus cosine of x times the sine of x plus cosine of x, right? Minus, this means the sine of x minus cosine times sine minus cosine. Okay, the only reason I started on the left side is because I looked at the right side and I said, well, that's 4 sine cosine, and there's a whole bunch more stuff on the left, and I'm just going to start with that and just multiply it all out, and then maybe things will just cancel and end up on the right side. That's what I'm hoping. We'll just see what happens. All right, so we're going to have to FOIL these. These are binomials being multiplied. So sine times sine, so that's sine squared plus 2 sine cosine plus cosine squared. I didn't show you how to do that, but I'm just FOILing, okay? Now, be careful because there is a minus sign in front of all of this. So let's go ahead and multiply all this stuff out and keep the minus sign in front because we're going to have to change the sign of everything once we multiply it all out. But just worry about multiplying first. So this is sine squared of x minus, so this is minus minus, so minus 2 sine x cosine x, and then minus times minus gives you a plus cosine squared. Hope all that's right. If we were in class, you guys would be like, Miss Halbach, you made a mistake. All right, so now let's see what we have. I've got sine squared in a different color. I've got this sine squared plus cosine squared. That's a 1. So I'm just going to go ahead and let's see. You know what? Before I do that, I lied. I'm going to distribute this negative because I don't want to confuse anybody. Okay, so let's rewrite this as sine squared of x plus 2 sine of x cosine of x plus cosine squared of x minus sine squared of x plus 2 sine x cosine x. Distributing the minus to the plus cosine squared gives you a minus cosine squared. Okay, so I don't even have to do that. I'm glad I stopped doing what I was doing because I've got a plus cosine squared and I've got a minus cosine squared. Bye-bye. I think I've got the same thing for a sine. Yep, I do. Sine squared and a minus sine squared. Bye. Look at that. Oh, that's all we need. 2 plus 2, 4 sine of x cosine of x equals, because that's simplified to that, 4 sine of x cosine of x. Boom, baby. See, this is fun. Okay, so let's go to F. Oh, I've got a negative inside this parentheses with this angle. We got to deal with angles all being the same. So we either have to change them to all negative or all positives. I'm just going to first rewrite cotangent because the tangent sine over cosine, so cotangent's cosine over sine. So I'm just going to go ahead and rewrite that first. And, you know, you don't have to do that. I'm just choosing. Oops, sine of x. Sometimes I put my x's in parentheses, sometimes I don't. Equals. All right, so that sine is even. Or sorry, oh my gosh, sine is odd. So that negative is going to come to the outside, and then I can cancel the signs. So let me rewrite that. We can also do at the same time cosine is even, so we can rewrite cosine. The cosine just goes, or the negative just goes away. So negative sine of x, and this is times sine of x. Now we can cancel the signs, but we still have that negative in front. Now I'm running out of room, so instead of just writing somewhere else on my paper, I'm going to make an arrow, or I'm going to let people know where I'm moving to so it's not confusing. You have to get in the habit of doing these problems and working down. Do not work across. Do not put an equal sign and continue across. We're working down. Okay, this is just how everybody does it. Everyone has to do math the same way. All right.